Hi, my name's Ali and this is my B101 presentation with DNS. Okay, so how did the DNS start? Computers connected to the internet through ARPANET. This was the world's first operational packet switching network. They all connected to one single file called host.txt. This provided mapping between host names and network addresses. The problem with this was that the whole internet relied on one single file. So if this file got corrupt or was deleted by accident, then the whole internet fell. That's where the DNS comes in. How does the DNS work? Basically think of it like a phone book. You basically go onto your phone, find the person you want to call, and you press call. That's what the DNS does. Instead of having to memorize a whole IP address, you just type the name of the website that you want to visit. And there you go, you're onto that website. The DNS has three main components: namespace, name server, and a resolver. The namespace gives the address its structure. The DNS uses a tree structure. At the top is the root zone, then there's the top level domains, then the domain names, and then the lower level domains. Basically, it works from left to right, so on the address. So on the left of the address is the lowest level, and at the top, the right is the top. Inside the namespace are nodes, which are separated by a period. Every address has to be unique, otherwise there will be errors or collisions. We don't want that happening. Example of a website address is facebook.com. There's two namespaces in this address, Facebook and .com, with .com being the top level domain. The name server. This holds information on the namespace. It responds to queries by outlining how domain addresses are to be translated. There's two types of name servers, authoritative and recursive and caching. Authoritative name server provides results when a query is made. There's two types of authoritative name servers, master and slave server. Master server stores the original copies of all zone records, and it does the actual query lookups. The slave server is an exact copy of this. It just helps share the load, so the master doesn't have to do every single query lookup. It can also serve as a backup to the master server. Then there's the recursive and caching server. This acts like an archive by storing the DNS query lookups, so the authoritative doesn't have to do every single query lookup every time a query is made. It can also answer queries much faster than the authoritative. Then there's the resolver. This translates a user's query from a domain name to an IP address and then back again. This is done so that the user receives the correct domain name and IP address. At first, the resolver is assigned a default name server. This is where it first looks at when it tries to resolve an IP address. If it can't find the answer there, then it asks the root server, which directs it to a name server with the correct data. How big is the DNS then? It's impossible to give the DNS a specific size. Supposedly there are 13 root servers, which isn't true. There are actually hundreds at over 130 different locations all over the world. You can look at the data size of the DNS, which is always increasing due to the number of registered domain names. But at the end of the day, you can't really specify the size of it. Legislation with the DNS. There isn't really a problem with the DNS itself. There's just problems regarding the domain name registration. Here are some examples. Sometimes people buy domain names that include brand names, for example McDonald's or Burger King or something like that, hoping to sell them to the companies for a large profit. There's sometimes people register domain names to embarrass their competitors, or sometimes someone registers a domain name to gain from another company. For example, if I registered the domain name containing Nike or Kit Kat, people are more likely to come to my site due to the fact that it has Nike or Kit Kat in my address. Limitations for the DNS. There's quite a few limitations, but there's two that I feel are quite important. There's typo spotting and cache coding. Typo spotting, basically an attacker registers a domain name similar to a registered trademark. This can be used to steal information, passwords, and all that kind of thing. A group called GoDaddy stole almost 120,000 emails just by registering a domain name similar to a registered trademark. and if the user missed out a dot, then the email would be sent to them. They found out that they could steal money, passwords, sales, all these kinds of things. Then there's cache poisoning. Basically, an attacker can insert a wrong addressing info into a cache, and this sends the user to a website which the attacker controls. And if the replica site is good enough, the user doesn't know if they're at the correct site or not. This was found out by a guy called Dan Kaminsky in 2008. He found the weakness in the DNS and he built the software to do it. But thankfully, he reported it, and security measures were taken to avoid this happening in the future. That's my presentation. Thank you for listening. I hope you enjoyed it.